Welcome to this explainer. Today, we're unpacking the invisible architecture of SGP22. Now, if you're wondering what that is, it's the GSMA specification that lets you remotely switch your cell carrier without ever having to touch a physical SIM card. We're going to be exploring the futuristic infrastructure that's literally running quietly in the background of your daily life right now. Here's our quick agenda for today. First, the consumer eSIM revolution. Second, machines versus consumers. Third, key architectural entities. And finally, why your consent matters. So, part one, the consumer eSIM revolution. Let's get right into it. Okay, let's dive into exactly what this is. SGP22 is essentially the master blueprint that turns your smartphone, your tablet, or your smartwatch into a fully remotely programmable device. By enabling the remote download, installation, and deletion of carrier profiles, it completely eliminates the need to ever swap those tiny, easily lost physical SIM cards again. It's an absolute game changer. Moving on to Section 2, Machines versus Consumers. SGP.22 doesn't exist in a vacuum. It sits right alongside a couple of other key GSMA specifications. There's SGP.02, which was designed for industrial machine-to-machine communication, and then the much newer SGP.32, which is built for simpler, highly constrained IoT devices. And looking at this really illustrates the macro difference here. SGP.02, that one is built for automated machines, trackers, and industrial sensors. But SGP.22, on the other hand, is engineered specifically for the consumer devices you and I interact with every single day. Your smartphones, your tablets, your smartwatches. Now check out the triggers here, because this is fascinating. SGP.2 uses a push model with zero user interaction. It just happens. But SGP.22, it demands a pull model. That means it has to be initiated directly by you, requiring your explicit consent and a brand new mandatory piece of software called the LPA. Which brings us to Section 3, Key Architectural Entities. All right, our very first technical node here is the eUICC. Think of this as a highly secure vault built right into the hardware inside your device. This vault is where all of your digital carrier profiles are securely locked away, heavily protected by strict cryptographic standards. No one is getting in there easily. Next up in our digital architecture is that LPA we just mentioned, the Local Profile Assistant. This software runs either on your device itself or directly within that eUICC vault we just talked about. It acts as the crucial middleman, managing the actual user interface you see on your screen and securely handling your local profile downloads. So, the really crucial point here is that the LPA is totally unique to SGP22. Unlike the machine standards where all the thinking and the logic lives far away in some remote operator backend, the LPA actually shifts all that control logic directly onto your personal device. Zooming out a bit to the network side of things, we have the SM-DP+. This is a heavy-hitting network node that safely prepares and delivers your digital profile package. It actually combines some pretty complex roles that used to be split completely apart in the older machine-to-machine standards. And finally, completing the network side, we have the SM-DS. This is an optional discovery service, and you can sort of think of it acting like a giant global digital bulletin board. It basically allows your device to check in and see, hey, are there any new incoming carrier profiles waiting for me? Okay, so let's watch how this digital handshake actually works in sequence. It's pretty cool. First, the SMD Plus securely pings the SM-DS. Second, your device autonomously checks that SM-DS bulletin board. And third, your device dynamically connects back to the SMD Plus to pull the profile down. It really is just a beautifully elegant user-driven loop. That brings us to Section 4. Why your consent matters. Look, because you personally own and control your smartphone, the standard had to change. The entire SGP22 architecture was fundamentally rebuilt from the ground up to strip control away from the remote operator backend, which is what we saw in SGP.02, and firmly give that power back to you. And through the LPA's user interface we discussed earlier, the standard strictly enforces an incredible level of security. Basically, absolutely no profile can ever be downloaded, installed, enabled, disabled, or deleted without your explicit physical consent at every single step of the way. But for certain highly sensitive operations, explicit on-screen consent just isn't quite enough. So SGP22 goes a step further and demands what is called a confirmation code. A confirmation code is an additional, totally separate secret cryptographic code. It basically ensures that absolutely nobody can remotely hijack your cellular connectivity without your direct authorization. It's a fantastic failsafe. As we wrap up this explainer, I want you to consider this. With SGP22 placing this level of ultimate cryptographic control directly in the palm of your hand, how will this invisible, consent-driven architecture evolve to protect and reshape the security of our connected lives tomorrow? It's pretty wild to think about. Thanks so much for exploring the blueprint of SGP22 with me today.